Hello friends, I hope you are doing well. A couple of months ago I decided to make my childhood dream come true. I think every child dreams of building some spaceship and flying to conquer space. I am not a child for a long time, and I am not going to build a spaceship either. Let's start small. Let's build a drone, quadcopter, aircraft, something really small and easy to build from scratch. Let's check which components are best to use and which are not. Let's try the most popular among those used for homemade DIY toys. We will choose what we need and collect something as cheap as possible, but really workable. I have already purchased some parts. One of the main spare parts is the motor. For our drone I selected and ordered simple and cheap size 720 brushless motors. Created and printed a 3D model of the simple workbench or stand for fastening the motor for the load testing. You can find a 3D model of the stand following the link in the description. So we have a motor, but how are we going to drive it? It's impossible to use the 5-volt outputs from Arduino. Yes, I'm going to use it as a drone controller, because the current at the output pins will be about 50 milliamps. The current strength required for the operation of the motors is 10 times higher than what Arduino will give us. Most likely Arduino will simply be destroyed under such loads. As the first candidate, I propose to test the L293D microcircuit, a very popular microcircuit for DIY toys, to control stepper motors. In the test, we will use the microcircuit circuit directly without an expansion board for stepper motors to make the test as plausible and understandable as possible. To create a test bench, we need a few more spare parts to make the test more visual. We will use an LCD screen, buttons, jumpers, many jumpers, 10 kilo ohm resistors, Arduino Nano, an expansion board for Arduino Nano, power supply. I will use two 18650 batteries as power source. I have fully charged both batteries beforehand. Let's put all together for our testing bench. Our circuit is ready. I think you have already noticed that I have added two buttons which will help us to adjust the speed of the motor, which will clearly help us test the microcircuit in more detail. Let's write some code for our testing bench now. So everything is ready for testing now. Let's upload a sketch and check out our test bench in action. This is the first launch. Okay, not the first one. I had to double check the connection of the jumper several times. As a result, it turned out that the batteries were not fully pressed into the battery case. As we can see, everything works as it should. The button works exactly as intended. It helps to increase and decrease the speed of the rotation of the motor shaft. We made sure everything works. Let's now check the current and voltage consumption. I reconnected the jumpers a little to include a multimeter in the circuit. As a result, our microcircuit allows us to supply about 700 mA to the motor, even though the batteries can deliver 20 amperes in the period and up to 30 in the peak. When microcircuit delivers 700 mA, it becomes very hot, so I believe it will lead to driver destroying very fast. The next step is to check the bandwidth for the voltage. In this test we got a much better result, because such a voltage is within the range permissible for this microcircuit. Based on the result obtained, there is a slight voltage loss. If we consider that fully charged batteries deliver 8.4 volts in total, then the losses are about 4–5% with an input voltage of about 8.4. So here we come such a difficult path, and we will be able to draw the following conclusions. The pluses can be safely attributed to the fact that this microcircuit is quite cheap, so it's very cheap actually, and functional when you're using motors for DIY toys, the functionality which does not imply the use of motors with high current consumption. By cons, within the limits of our initial task to create a drone, we can safely attribute a small current bandwidth, which makes it impossible to use this microcircuit for our purpose to build some drone. I think our small motors will draw about 2 amps at maximum load, which is clearly more than 0.7 amps we got in the test. Thanks for watching. Write down in the comments below how you control the motors in scenario like ours to get maximum performance for a drone motors driving a low cost. Bye and do your best.